61. The ratio of units of van der Waals constant A and B is. In the van der Waals equation, we have van der Waals constant A and B, and we need to find out the ratio of the unit of A to the unit of B, and that would be equal to the unit of A is atmosphere liter square mole inverse square, and that should be divided by the unit of B. Unit of B is liter mole inverse, and if you simplify it, you will find out this is atmosphere liter mole inverse. This would be the unit, and that unit is given here in option 2, and this is my correct answer too. After this, question number 62. Now question number 62. Equilibrium constant of a reaction CaCO3 in solid state is getting changed into CaO in solid state and CO2 in gaseous state is 0.1 mole per liter if 0.2 mole of CO2 gas is added in above equilibrium, then the active mass of CaO will be. In this particular reaction, if you look at this, the reactant is calcium carbonate and the products are calcium oxide and carbon dioxide, and you are just going to add carbon dioxide above equilibrium, and you just want to find out the active mass of CaO. We should always know that whenever we talk about a solid substance, its active mass is always considered as unity, and on that basis we can say that the active mass of CaO, that's in solid state, is 1. And on that basis, option 2 is the correct one. And it's a turn for the next question. Let's take that. Question number 63. The heat of combustion of P4, that's white phosphorus, to P4O10 is minus 5.4 kilojoule per mole. The heat released upon formation of 28.4 gram of P4O10 is. Now, in this particular question, first thing is here, that is the heat of combustion of P4 is given, and that is minus 5.4 kilojoule per mole. It means the process is there, that is combustion of white phosphorus. I'm just writing here the reaction, and here's the formation of P4O10. Let's balance this reaction. This is the balanced reaction, and during this process, this combustion of P4, there is the formation of heat also, and that heat is enthalpy of combustion or the heat release simply, that is minus 5.4 kilojoule per mole. It means during the formation of this 1 mole of P4O10, the heat released is 5.4 kilojoule. Now, you just want to find out the heat released upon the formation of 28.4 gram of P4O10. So, first we need to change this mass into moles. Then we'll find out the how much amount of heat is released. So, the moles of P4O10 would be equal to its given mass upon the molar mass. What is the molar mass of this P4O10? That is 284 gram per mole, and that's why the mole formed here are 0.1 mole. Now, if you look at this given chemical equation, you will see that this phosphorus is there and its formation enthalpy is considered as 0 by convention. And if we talk about oxygen, it is in standard state, elemental form, that's why its formation enthalpy is also 0. So this enthalpy of combustion which is given here is equal to the formation enthalpy of P4O10 also. So we can represent it as this enthalpy of combustion for this particular process. This P4 is equal to enthalpy of formation of P4O10. We can take this and these two are equal, and that is minus 5.4 kilojoule per mole. Now, on the basis of this, we can say that formation of one mole of P4O10 releases 5.4 kilojoule heat. Then definitely during the formation of 0.1 mole of this P4O10 will be formed and release 5.4 into 0.1, that is 0.54 kilojoule heat. This much amount of heat is released, but the answer is given in joules, so I'm just going to change it into joule. It becomes 540 joule by multiplying 10 raised to the power 3. So this is 540 joule, and this is given here in option 2. That's why the correct answer for this question is option 2. Now, after this, let's take next question. The work done and internal energy change during adiabatic expansion of a gas from volume of 2.5 liter to 4.5 liter against a constant external pressure of 5 atmosphere respectively are. And the value of this 1 liter atmosphere in joules is also given. Now, this is the process which is adiabatic expansion. And we need to find out the work done and internal energy in this case. We should always know that whenever we talk about adiabatic process, always this Q is 0. It means in that particular case, the change in internal energy is equal to W. Why it is W? Because we know that delta U is equals to Q plus W. Q is 0. That's why delta U is W. Now, let's find out this W work done. That is equal to P delta V. Pressure is given. That pressure, let's place the value. Pressure is 5 atmosphere. It's given in the question. So it's 5. What is the change in volume? V2 minus V1. So this V2 is 4.5 minus V1 is 2.5. That is 2. It means 5 2s are 10 minus 10 liter atmosphere. This is the work done that you have to do here. And that is also equal to delta U. That is minus 10 liter atmosphere. But the answer is given in joules. That's why let's change it in joule. It can be converted into joules by multiplying 101.3 to it. And this would be equal to 1013 joule. The negative value is there. And that answer, that both the values are same and both the values are negative also. Minus 1013 is given in option 3 for both work done and internal energy. That's why this is the correct answer for this question. After this, let's check next question. Question number 65. The solubility of AgCl having solubility product 1.6 into 10 raised to the power minus 10 in 0.2 molar NaCl solution will be. In this case, we have AgCl and solution is prepared in 0.2 molar NaCl. It means the ions which are formed here are these. Now, let's assume the solubility of silver ion is S. Similarly, solubility of this chloride ion should also be S. But one thing you should always remember that in the question it is clearly mentioned that AgCl is present in 0.2 molar NaCl solution. It means the solubility of chloride ion is due to this NaCl solution also. So, the total concentration of this chloride ion is S plus 0.2 molar. And one more thing is also there. Due to the presence of common ion, this chloride ion is the common ion here, and due to its presence, the dissociation of AgCl would be reduced. And definitely in that case, the solubility of chloride ion is 0.2 molar only. Why? Because S value is quite low. That's why. So in this case, this is equal to 0.2 only. Now, we know that solubility product, that KSP value 1.6 into 10 raised to the power minus 10, that's given in the question, is equal to the solubility of these two ions. So it would be S into 0.2. So the value of S is equal to 1.6 into 10 raised to the power minus 10. That's divided by 0.2. And this value is equal to 8 into 10 raised to the power minus 10 mole per liter. This is the solubility of the salt AgCl, and this is given in option 2. So you should choose it as the correct option. Now after this, let's take next question.